So welcome everyone, and thank you for joining this remote storytelling large datasets breakout session today. My name is Jesus, and I will be co-chairing this session together with Sonia and Amber. Sonia and Amber, say something, please, like hello.
Hello, welcome, and thank you very much for being here. We're very much looking forward to this session, and we appreciate your participation. I have shared notes documents, which I will share yet again. Open notes documents that you can help to take notes and put any questions you have for the sessions.
And hi, everyone. I'll take a look at the chat and help Jesus and Sonia.
Thank you, ladies. So I already showed you the etiquette rules for this session, so please be so kind to follow them. And as you know, big data is all over these days, and more people want to share large data collections using Dataverse. But if you ask me, this has not been a trivial trip. We are discussing about big data and Dataverse for some years now, and I think at this point we are much closer to having a stable set of tools to deal with the problems normally associated to large data files management. And that is why I like this session, because today we are going to look at real problems and real solutions related to large files management and sharing with Dataverse. And those problems are normally related to two main topics. The first one is a low bandwidth connection between the user's computers and the repository, or the protocols used for file uploads that prevent lots of users from uploading large files with the native functionalities provided by Dataverse. And the second one is the unaffordable costs related to storing those large files in typical cloud servers or content delivery networks, as well as the high costs of outgoing bandwidth when dealing with terabytes of data. So let's start with a brief summary of what we will see and discuss in the coming 1.5 hours. Firstly, Kate Dreher will present us a real use case of large research data files that could not be shared using Dataverse at the time because of an unaffordable storage solution. This includes genotypic data for you to have an idea of the dimension of this problem. Then Ben Golub will introduce us to an innovative, decentralized, remote storage solution based on blockchain technology, which is another trendy topic as well, even more than big data, I would say, and shows the impact of this technology beyond Bitcoin. After Ben, I will present a pilot solution to Kate's problem using Ben's technology. So I hope this will be a nice way to close this circle. And then Jim Myers, Dedrick Kirmis, and Matt Harp will explain and demonstrate a command line bulk uploader for Dataverse in a couple of presentations. And our last presenter, Vas Vassiliadis, will speak about the integration of Dataverse and Globus. After the presentation, and as usual in these community meetings, we will have a discussion among presenters and attendants. So your questions are mostly welcome, and we will strive to answer all of them. So I hope you will enjoy the program we are offering to you today, and say goodbye for a while handing over to Kate Dreher with the presentation entitled Exploring the Costs of Freely Sharing Data Through Dataverse at Summit. Thank you again for your attention.
Thank you, Jesus. Is everyone able to see my screen now?
Yes.
Excellent, thank you. So I would like to start by thanking all of the participants and thanking the organizers for giving me the opportunity to present in this session as a user who is looking into options to be able to make large data sets available through Dataverse at Summit. And in the brief time that we have for these presentations, I'd like to just introduce Dataverse at Summit to give you some of the context, then to speak about some particular large volume data sharing use cases that we have, describe a little bit about a search for a solution to be able to provide these data to our users, and then the next steps that we're taking that should hopefully be a good segue to the following talks, as Jesus mentioned. So to start with, I just wanted to mention that this is, we're referring to Dataverse at CIMMYT, and for those of you who may not be familiar with this organization, this is the Spanish acronym for the name of our organization, the International Maize and Wheat Improvement Center. We're a member of a large consortium of institutions around the world that are focusing on reducing poverty and enhancing food and nutrition security and improving natural resources. But the particular focus of CIMMYT is on maize and wheat science for improved livelihoods. And therefore, a lot of the data that we are presenting in our Dataverse are related to maize and wheat research and breeding efforts, genetic resources data, and also data from our programs that are working on sustainable intensification, socioeconomics related research, and also on integrated development. And these data are collected from our headquarters, which is based in Mexico, as well as various sites around the world, as well as from collaborators that are working with us on projects and longstanding partners that we have. And so these are some of the sources and types of data that we're trying to share with the public through Dataverse. Our institution and our consortium has a commitment to open access to data. And so at CIMMYT, our Dataverse has 6 publicly available collections of data. 2 of those are general institutional collections that provide research data and information about research software. And then we also have some smaller collections that are focused on data that have been generated through special projects. And I showed 2 examples here from the International Wheat Yield Partnership and also from the Cereal Systems Initiative for South Asia. And across these different collections, we want to share data for various different reasons, both to be able to disseminate data that's been captured by research networks that we have with CIMMYT and collaborators, to share software that's been developed at CIMMYT. For example, our biometrics program has worked on making some R-based applications that can be used for analysis and breeding programs. We want to be able to host data sets that have been generated by particular projects that may be deliverables for those projects. And then we also have many cases in which we're trying to provide supplemental data for journal articles as researchers within the organization are publishing the results of their research. And so there are many different types of data that are generated by these different programs related to maize and wheat. But I'll just show 2 examples of data types of data that we have received requests from in our data management team to be able to provide access to through Dataverse. And one of those shown at the top is aerial imagery that's used for crop phenotyping. You can see there are various different methods of collecting this. We can get hyperspectral or multispectral or thermal images. Hyperspectral are typically the largest in size. We can also have videos that are collected as part of phenotyping efforts. And I just provided a very rough range of sizes here. You can have relatively small files for thermal images, but when you get up to the hyperspectral images, each individual file can be relatively large in size. And since these are being captured, there is a desire to be able to share these with the public. They could be used for algorithm improvements, et cetera. Probably not a very high number of users who may be able to take advantage of these images, but it is something that we have received requests to be able to share. And then another use case that I'll focus on in more detail are genotypic data that have been generated about maize and wheat materials that are available at CIMMYT and partner institutions. And when we're sharing these data, typically within Dataverse, we are able to share processed files where we have formats such as HapMap or VCF, which some participants in this call may be familiar with. But even with those types of condensed formats, the sizes may exceed the current limits that are available for individual file upload in Dataverse as the number of samples and the number of markers that are analyzed increases. But we've been able to share those reasonably well. However, our greater challenge has been with the underlying sequence data that supports these condensed file formats. And we have issues either in that we may have thousands of individual files that could fit in Dataverse. They're only in the megabyte range, but there are thousands of them. Or if we have condensed files, then the numbers are smaller, but the sizes are much more significant. But we are actively being requested and have an obligation to share these data with the public. And so I just wanted to show two specific use cases that we had where CIMMYT holds a collection of diverse materials in a germplasm bank. And there have been efforts to look at the diversity of these materials through genotyping. And so within Dataverse, we have two studies for maize and wheat. And we provided the condensed files, but when we looked at the underlying sequence data that we would want to be able to share with the public, you can see that the sizes were significant. I mean, not huge, but a challenge to be able to share both on the maize and the wheat side. And so we were looking for options to be able to provide these data to the public, and we turned to our wonderful knowledge management team who is providing Dataverse at CIMMYT, and basically asked if they could help to enable users to click on the download button in Dataverse as they would for any other file, agree to the terms of use for the data, and then be able to easily download these high volume data sets directly from Dataverse. That's the easy solution that we were looking for. And so thankfully, the knowledge management team was able to go out and look for potential solutions and came back to us with information about the possibility of using a content delivery network. They did an analysis of some of the potential providers, and some of the options that they looked at were Amazon, CloudFront, Azure, CDN, in both hot and cool modes. Let me see if I can move the and then based on the different features that were available and then the different costs available for hosting the data as well as for enabling downloads, we tried to generate some different scenarios and to look at the cost of those. And we looked at sort of very high levels of data storage and very optimistically high levels of data downloads per month, to quantities, smaller quantities of data and much lower frequency of download of these data sets. And the overall conclusion was that in general, all of the scenarios, even the lowest cost options, would require a substantial and perpetual ongoing budget allocation. Just to give you a little bit of a sense of the magnitude, if we were looking at even the lowest cost option where we had 100 terabytes of data that were being stored perpetually as well as fewer than one download per month of those files, it was costing over $28,000 per year from our cost estimates. The hosting costs were not necessarily exorbitant per month, depending on the quantity of data that we were storing. If it was in the 100 terabyte range, it could cost between $1,000 to $2,000 per month, depending on the storage option. But one of the costs that had a very high impact were the number of downloads. So once we made these files available, we knew that if they were popular, that the costs of downloading those terabytes of data could increase rapidly. And as you may have seen from the May study, we did have over 1,700 downloads of the files associated with that. So based on those high cost analyses, we determined that we wouldn't be able to implement that as a solution at the time. And so we moved ahead again with great support from our KMIT team to find interim solutions. So at the moment, we still have those studies published in Dataverse. We have a data request file that's available at Dataverse. The users can download that and then send that to us at CIMMYT, and then we're able to provide temporary access to the files via FTP or Globus. This is a sort of manual solution that we have in place now, while we continue to search for integrative, cost-effective solutions to be able to provide easy access to these large data sets directly from within Dataverse. And I'm really looking forward to hearing about more of those options in this session today. So with that, I think we may not have time for questions for individual sessions, but I'd be happy for any questions, comments, or suggestions at my email. So thank you very much.
Thank you very much, Kate. We'll do the questions at the end, just so we can get through all of the presentations. And we did get about 3 questions that came in pre-conference, so we'll include those as well. Amber, you can go ahead and if you want to do the next introduction.
Sure, let me just check okay, so next up we have Ben Golub from Storage. He's the CEO of Storage, and the presentation titled is A New Model for Globally Sustainable Decentralized Storage. Go ahead, Ben.
Great, and are you seeing the presentation?
Yeah, it looks good.
Oh, great. Okay, well, thank you for inviting me. This seems like a really exciting panel, and it actually, in some cosmic way, brings together a lot of the things that I care a lot about and have done over my career. So I've spent most of my professional career in sort of the decentralized computer storage space. So I'm currently CEO of Storage, which is a decentralized storage company. Prior to that, I was a founder and CEO of Docker, containerization company, which is being discussed at a number of other sessions in this conference, Gluster, open source storage, and 5 other startups before that. But I actually started my career doing research in a data-intensive way into agriculture. So I feel very connected to the folks at CIMMYT. And actually some of the lessons from doing agricultural policy work early on actually inform a lot of the design behind storage. So if I were sort of to take a step back to a lot of what I think, as the world has learned about agriculture and how to make agriculture sustainable, a lot of it boils down to making sure that you're avoiding concentration and striving for openness. So when you have land too heavily concentrated or wealth too heavily concentrated, or you're, have a monoculture of only a few crops, or if pricing is sort of controlled by only a few people, things tend to get bad. If information isn't shared, it tends to be bad. I think that this is not only true for agriculture, but actually for the world of storage. And unfortunately, as we just heard, and the world of cloud storage right now is sort of the opposite of, it's a very concentrated, very unopen world. So even though the world is creating lots and lots of data, and the world is going to create about 44 zettabytes of data this year, which is enough to fill a stack of CD-ROMs to the orbit of Mars and back, and is growing by 30% or so every year. And most of it's being created and analyzed and consumed at the edge. Most of the cloud storage is actually heavily concentrated in centralized data centers, with one of 3 companies, Microsoft, Amazon, or Google, who happen to also be 3 of the largest companies on the planet, and all happen to be in the business of selling data and mining data. So in many ways, it creates a lot of security questions, a lot of concentration questions, and pricing questions as well. So even though we've had Moore's law operating for a long time, in the past 6 years, the prices of storage, both storage and especially bandwidth, have only come down by a few percentage every year, even as the amount of data is doubling. And of course, we want to have support projects like Dataverse and others. And so, as we think about it at Storage, if we've got a world of data that looks like this, and this is sort of the Dataverse map, we think storage should look like this too, right? Where it's globally distributed. And at Storage, when I explain it to my family at Thanksgiving, I say we're sort of like Airbnb for disk drives, in that we've enabled people who have spare space on their drives all around the world. It's individuals, it's data centers, it's research institutions. We enable them to rent out their spare capacity. And we've built what amounts to 50 petabyte data center of storage, but without pouring a single bag of concrete, using any additional electrical power, et cetera, and it's globally distributed. So each of the people who's running one of these nodes is getting compensated for the data that's stored on them. But we've also managed to do it in a way that ends up delivering incredible economics, incredible security, incredible performance, incredible durability as well. And so I'll talk a little bit about how we do that. Our service is called DCS, Decentralized Storage. And the basic way that it works is we've got a network of storage node operators who are compensated based off of how much they store and how much bandwidth they provide. We've got our customers who've got applications, and these can be S3 compatible applications, or we've got native libraries, and then a set of what we call satellites, which are basically distributed metadata servers that have the minimal amount of metadata that we need to have in order to sort of track where all of the storage is and enable it to be retrieved. If I double click on the way this works technically, anytime a file is uploaded, it is encrypted before it comes to our network, generally using keys that only the end user has. So for highly secure applications, that means that we can't mine the data, even if we wanted to. We can't, people who are running the nodes can't see the data. The only people who have access to the data are the people that you choose to give access to. After the data is encrypted, it's then split up into a number of pieces using a technology called erasure coding, which basically is a way of splitting up a file so that you can have X number of pieces that split in up to, and any smaller number, Y, can be used to put it back together. In our case, we split each file into 80 pieces, of which any 29 can be used to put it back together. And then each of those 80 pieces goes to a different drive on the network run by a different individual or company on a different network, different power supply, different geography. When you want to get that file, we need 29 of those, 29 out of 80, to be able to respond and deliver the file. And turns out when you do things like this, you get a lot of really great results. First of all, you get exceptional durability. So for a file to be lost, you would need to have 51 out of 80 drives simultaneously fail. And these are all, again, run by different people in different geographies, different power supplies. So you could have an asteroid hit all of, take out all of Europe or all of North America, and you wouldn't lose your data. Now, my guess is you'd have bigger concerns if that happened than losing your data, but nonetheless, we're incredibly resilient. We haven't lost a file in over 2 years of operation. But you also get incredible security. So attacking a file requires identifying, finding 29 different drives, compromising them, and then getting the data from them. And even then, you're only going to have an encrypted file, and the next file is going to be hidden the same way. So, for use cases where the sensitivity of data is great, like healthcare data, this is a great solution. It also happens to be incredibly performant because if some of the drives are running slow or some of the networks are congested, we're able to choose from the fastest drives that happen to be available. But probably of most concern is that this is incredibly economical. So for the people who are running the drives, it takes no extra power, no extra equipment, no extra people to run a drive at 80% full versus 25% full. And most drives on the planet are less than 10% full, as it turns out. And that means that we're also able to do things very economically as well. So we're able to price profitably at about 1/10 to 1/40 the price of AWS, and even more so for high bandwidth use cases, and even more so for multi-region use cases. And it's transparent, open source, et cetera. So as a result, this network is growing very rapidly in terms of operators, in terms of customers, and also in terms of native integrations into us. So a lot of the key database and analytical frameworks are getting built into us natively, in addition to being S3 compatible. And among the use cases that we're seeing a lot of is academic data sharing. So the two institutions here are dealing with a lot of the same problems that CIMMYT and others are, where they've got large data sets. In one of these cases, it's a large physics data set, and the other, it's a large Monte Carlo simulation where people can have terabytes of data where they either need to control access or need to have fine-grained control, and they want to enable people to be able to download it rapidly from around the world. And the structure here ends up delivering that pretty well. And we're very excited by the performance that we're seeing, which is on par with or better than Amazon, but for a fraction of the price. And obviously another concern that many of the people in this field have is that the data has integrity. And given the way that we've structured this, each of the nodes, which is storing just a sort of an encrypted blob of data, is given a lightweight cryptographic challenge to solve on a regular basis to prove that they're storing what they should be storing, which means that it's impossible for any node to sort of either intentionally or unintentionally corrupt the data. So you end up having data integrity, which is especially important for delivering reproducible results with data. So I'm going to see if I can get this to work right now. I'm going to show you a quick demo, and I know Jesus is also going to be doing this as well. So a picture is worth 1,000 words. So hold on just a moment here. So here I have a file. It happens to be from CIMMYT that I got off of the Dataverse, which is pictures of maize ears, and you can see that it's globally distributed around.
Just a time notification, Ben. A couple more minutes, please. Thank you.
Okay, will do. I'll make it very fast. If I wanted to upload another file here. I'm going to upload another file from CIMMYT. These happen to be, again, pictures of ears of wheat, and you'll see that this is happening very rapidly. And if you look at the details of this particular file that I've just uploaded, we'll see it in a second. It happened to have been distributed all the way from Hawaii to Siberia, and I can share that with you now and then give it to you to be able to download. And these two happen to be small files, but this also happens to work really well for large files as well. And it actually even works for storing and scrubbing 4K video. So slightly more exciting than pictures of ears of corn. We've got this is a 4K video of rabbits and running around. But what is happening in real time as we're doing this is this video is being served, and it's not being served from a data center. It's in fact being served from 880 different locations around the world. And the fastest ones that are able to respond are seeing it. And so you're seeing live 4K video, which is exciting, but it's being done in a highly secure way. And as we're doing this, people in New Zealand, people in Cape Town, people in Cairo, people in Dubai or Recife are being compensated for doing this. And so we think this is a very exciting way to sort of enable data sharing, but also to enable sort of a different way of thinking about storage. And I'll end quickly here. Here's a link if you want to learn more, with links to some case studies as well as more about the product itself. And of course, we're excited to have anybody who wants to either be a customer or rent out their storage drives to come contact us.
Thank you, Ben,
Thank you.
very much. I'm actually going to make time for two questions because one is related to what you just presented. And the other one, I believe, was for Kate from Jim Myers. So Kate, we had a question. Did you estimate costs without a CDN lawyer, just download from S3 on AWS, for example?
At the time that we were doing the estimate, we were focusing on a content delivery network, since that was what was recommended by the knowledge management team. So we did not do an independent assessment of that. Thanks.
Okay. And I do have one more question, if I could find my document. Here we go. Give me 1 second. I have so many things. Okay. The question I think is for you, Ben. When using encryption, and this is from John Crabtree, I believe, when using encryption for storage devices, how do you preserve the keys? The archives need a plan to preserve the keys if you use this type of storage. The single point of failure seems to be the keys. Maybe a second preservation network for the keys?
Yeah, so we're pretty compatible with a lot of the different key management systems. So we don't sort of as a point of design, we don't hold keys because we don't want to be a point of failure, but we can work with sort of key recovery systems and things of that nature. And probably a bit too detailed for this session, but there's a very flexible and hierarchical way of generating unique keys for everybody who you want to share data with. So we combine encryption and access in sort of the same construct, so that if there are certain data sets that need to be shared with certain people, some people get read access, some get write access, et cetera. That happens in a very flexible way, and it also happens at the edge, not with a centralized access control list.
Thank you. Okay, Amber, it's on you.
Okay, thanks everyone. Thanks, Ben, for that. And thanks, Kate. Our next presenter, you have already been introduced to, but I'll just introduce him again. Jesus Herrera de la Cruz is the Digital Innovation Manager at the International Maize and Wheat Improvement Center. And Jesus's presentation title today is A Pilot Integration of a Blockchain-Based Storage Solution with Dataverse. Take it away, Jesus.
Thank you, Amber. So hopefully you can see my screen and my presentation, full screen. Am I right?
Yes.
Thank you for the confirmation. So firstly, I would like to thank my colleagues Alejandra Tenorio and Gerardo Flores, who are colleagues here in CIMMYT within the Knowledge Management and Information Technologies unit. Because they helped a lot in the development of this pilot integration between Dataverse and storage, the amazing tool that Ben just presented us. So, oh, I cannot make this Now, so as you already know, Dataverse is compatible with S3. Sorry, is compatible with S3 compatible storing solutions for a long time now, and maybe Amazon S3 has been the most linked one to Dataverse installations. But as we could see in Kate's presentation, it's about money that we are not using the Amazon S3 storage to share our large data files. And if we do a really simple exercise and we try to store a 10 terabyte file for a month, just a month, not forever, because you know that repositories are here to archive files forever in theory. And let's think of a single month, and we will download this file just once, which is not reality. Then how much money would we pay for doing this in Amazon? You have it on the screen. I don't want to read the number because it's a bit impressive. So I got to know about storage by reading on blockchain, and when I saw that it's S3 compatible, I suddenly thought, wow, we can connect that to Dataverse. And look at the costs. I mean, 90% off in this example. So that's what moved us to pilot this connection between Dataverse and storage, and not only because of the cost, because of these other features that Ben already mentioned, like encryption or distributed storage that avoids single points of failure. That's very important to techie guys like me dealing with servers. I mean, to avoid a single point of failure is like magic. And you get similar behavior to a content delivery network in the sense that you will retrieve the pieces that make up the file from the lower latency nodes. And now I will show you a video in which, in a nutshell, you will see how to connect Dataverse to storage.
The first step to integrate storage with Dataverse is to create a project in storage, as simply as naming it. Once you have your project created, you define your access permissions, as you can see on the screen. Then, you will get your encryption passphrase to access the data from the web browser, and the access token for web applications. And finally, you will generate your S3 gateway credentials. You will then have to copy the access key, secret key and endpoint information to use them for the configuration of Dataverse. Now that you are all set with the storage credentials creation, you will run some AWS commands to configure Dataverse. Here you can see how easily you can configure the access key, the secret key and the region. And then, you just need to test the connection to storage. The next step is creating a bucket to store the Dataverse files. You can list the content of the newly created bucket to see that everything worked fine. Not only that, you can go to storage as well to see that the bucket is there. Now you are ready to configure your Dataverse installation to use an S3 compatible storage. You will need to run some more commands to get this configuration done. Just follow the instructions given in the Dataverse online manual. And after the configuration, you are ready to create a new Dataverse that uses an S3 compatible storage, as you can see now. Finally, you can create a new dataset and its files will be seamlessly uploaded to your storage. Mission accomplished.
So that's it. And I mean, I hope you could hear the sound of the video because it was not very loud. And well, while we were trying to connect storage to Dataverse, we got to know about Wasabi, which is a similar competitor of storage. I mean, there are several of them. You can find them on the web by Googling like kind of S3 compatible storage decentralized solutions. And I mean, you can see that we have competitive costs as well with these other tools. And all of them are S3 compatible, and then they can be easily connected to Dataverse as well. And so after these testings, we are in this state now. We want to finalize the upload and download testings with increasing file sizes, and we are collaborating with the storage team to get this done. They are helping us a lot, and once we are sure that this will be a usable solution, we would like to develop a user-friendly interface to configure the integration of these S3 compatible storage solutions with Dataverse, because I mean, it would be easier if we have a user interface instead of writing all those commands on the command console. And I mean, the next stage is to start sharing large data files at an affordable cost with the universe, thanks to very competitive solutions like the one mentioned and explained by Ben. So thank you everyone for joining me in this presentation today. If you have any questions or comments, happy to answer them.
Great, thanks. And I see, Ben, you've answered that one question from Ingrid in the chat. That's great.
Yeah.
So Sonia, are we good to go to the next presenter?
Sonia, you're muted.
Yes, Amber, thank you.
Okay, great. So our next presenter is Jim Myers from the Global Dataverse Community Consortium, and Jim's presentation title today is Going Direct for Larger Data Uploads.
Thanks, Amber. You guys can hear and see okay? Okay.
Yes.
So I want to kind of back up to give you a little bit of history and then sort of go through partly the discussion of storage in Dataverse and partly to focus on the S3 in specifics. So when we're talking big data, again, there are orders of magnitude beyond what our community is talking about as big data with terabytes, but really, you know, coming from where we were, getting to gigabytes, tens of gigabytes up to a terabyte, what has really been the problem so far that people want to deal with. And that there were problems in that when you do that with files, the uploads themselves have been handled by Dataverse. So the files go to the Dataverse server, they go on the same file system that Dataverse has been on. So it takes the bandwidth off of that server, it takes the processing power of that server, it takes up the same storage that's used for logs and other temporary files. So we had various problems that people have run into over time, from, you know, unexpected uploads sort of running you out of disk space and crashing everything, the costs of that local storage and managing it, you know, because file systems aren't as reliable as a lot of the cloud and S3 type of storages, and Ben's stuff you just heard about, you know, dealing with backups and so on. We also had people, again, for bandwidth and speed, that they had timeouts. And with Dataverse, again, because there's usually there may be a load balancer sitting in front of Apache, sitting in front of Glassfish or Payara. There were multiple places you could have timeouts, and kind of became hard to figure out, if somebody was having trouble uploading, how do they do it? There's also the larger issue that I won't go into the technical details, but when you sort of stream a single thing over HTTP, you're not necessarily using even the whole bandwidth that you've got available from your machine. So you sort of have an additional problem. So over time, Dataverse has made things a lot better, particularly with S3 support. So S3 itself, one of the things it allows you to do is essentially, unlike a file system where you have to be local to talk to it, it's an internet protocol, right? So you can talk to things where the storage is somewhere else. So whether that's another machine local to you, or it's often a commercial cloud provider, and so on, you basically separated it out from the operations of the Dataverse server itself. And again, that the one thing I'll point out with this is that, go backwards here again. The thing that we often talk about is, so it's S3, we're talking Amazon. That could be your own compute center. And in fact, there are things like MinIO that you put on top of a local file system, and you can run your own. And again, the things we've heard about today are other options. So S3, doesn't limit you to having to go, buy commercial stuff. There are a lot of ways to use the S3 protocol. But I came into Dataverse around 2018, and by then I think already we had the idea of direct transfer downloads. S3 itself, it started out with Dataverse talking S3, but for downloads, Dataverse was basically able to redirect your browser to go direct to the other S3 store and do the download directly. Part of what I did coming into Dataverse a little bit early on was to start looking at how you could do the direct upload as well. So again, the transfer from your browser to Dataverse, you'd talk to Dataverse and say, yes, I'd like to upload a file. And it would say, great, here, go talk to the S3 service directly and go upload it. So one of the benefits of this, and one of the things that makes it harder for some of the other storage things that people have looked at with remote stores, is that Dataverse is trying to continue to manage access control of these things, right? Dataverse doesn't want to give out, not everything is public. If you've got restricted files or things in draft state, Dataverse is trying to control the access. So this thing called pre-signed URLs that's available through S3 is essentially a way that Dataverse can delegate a credential to you just to do that one upload or just to do that download once, and it times out within a few minutes. And so Dataverse is still able to easily access manage the access control like it wants to. So this does a few things. It sort of minimizes the impact on Dataverse and its server because you're not really doing the transfers or the storage there. There's also fewer timeouts. You just basically have to get S3 set up so that it allows you to do things and not have to deal with the multiple layers I talked about. So sort of pre the last meeting we had together, we had S3 protocol support and direct downloads. In 2020, supporting, I saw TDL's name go through the chat here, but basically the origin of getting to allow multiple stores in Dataverse so that you could do some things on files, some things on S3, or an S3 store for small files and a different one for big files and so on, was supported by their efforts. We went from multiple stores and we did direct uploads. And at that point, direct upload was essentially single part files. So basically, if you wanted to upload something up to 5 gigabytes, it went in one HTTP stream. What we've done in the last year is go to multi-part uploads, which essentially lets you go A, to bigger files, and B, it actually does uploads of larger files in multiple parts. So if you have a 20 gigabyte file, you can split that into 100 parts and send them all in parallel, which allows you to use a lot more of your bandwidth. And that's sort of one of the tricks that Globus does in the FTP world, right? That they're able to use a lot more of the bandwidth you have available because there's parallelization. That also allows you to do some fun things with make it a little bit more reliable, because rather than waiting to the end of 20 gigabytes and finding out your last byte didn't get through, when you break it into parts, if you fail at a given part, you only send one part back through and it'll reassemble on the far side. So that's now part of the API. It's been out, I forget what version, 5 point something. that's in there. There's also now, we used to have direct uploads for new files. The replace functionality also does direct uploads now. I think more of the Leonid has put in more of the auxiliary files, which usually aren't as big, but they can also do direct downloads now in the latest. Sort of coming beyond this, part of, I won't say anything much about the Globus effort, but part of it, it was helpful for, I didn't do my timer, sorry. Part of what we got out of that was Dataverse usually tries to update the data set after every file, and now we can do it after multiple files. So it's another optimization. We're looking at things like a storage analysis tool to make sure that you don't have files or partial files that are in your S3 bucket costing you money that aren't actually data that's stored in the Dataverse. And then again, there's Globus work you'll hear about. The remote store is coming along as well from Odin and so on. So practical guidance on the S3 side. And again, I think, you found lots of, new interesting things for other S3 providers in the presentations today. But once you find an S3 provider, as you saw in that video, you can set up a store. Harvard is doing things like setting up, separate stores with higher limits so that they can only allow people in certain Dataverses or certain data sets to access the larger store. So you can sort of keep the, most people can upload to this amount, but when they talk to you, you can do something else, give them larger access. Definitely enable the direct upload, not download to make it faster. And then, for a few files, the direct upload and even the multi-part upload is actually part of the standard Dataverse UI at this point. So if you have one 50 gigabyte file, just drag and drop it into your browser and it should work. The thing that I think Deidre and Mark will talk about a little bit more is the DVUploader. It's essentially a Java tool that does those direct uploads with Dataverse and does everything that's needed to using the API. And it's a tool that you can point at a folder and it will upload all the files in the folder for you. So when you start getting to the thousands of files that add up to gigabytes, the DVUploader is probably better than trying to drag and drop files into the UI. Cost considerations, you've certainly heard about other options today, but even with the major providers, there are colder and slower options. I think there are even things where you can charge back to have the downloader get charged for the transfer costs and those sorts of things. So you might be able to think about those sorts of things to reduce costs. The other thing is that one of the things that TDL was interested in this for is that because they're actually a consortium of universities that have compute centers, having one store per institution where that institution's data and big data could potentially go back to that institution gave them a sort of an accounting mechanism to have a per project or per institution mechanism that they might be able to, essentially whoever's running the S3 store is managing the costs. And so rather than the library doing it, that would be a way out. And I don't want to, again, say anything of how they're actually doing that, but at least in terms of where they were thinking about that was part of the motivation to begin with. So I think that's it for me. Thanks.
Thanks, Jim. So there's a lot of questions now that are getting recorded in the notes, but in the interest of time, I want to make sure everybody has an opportunity. So let's move on to our next speaker. So Deirdre Kermis is a web application developer, and Matt Harp is the research data management librarian, director of research data services at Arizona State University Library. So thank you to both of you. Take it away.
Yeah, thanks for having us. This is a great conversation, and I think moving forward, this is a great time for us to jump in and start talking about it, because we're going to share a recent use case that we've just had related to the direct API, direct upload process in Dataverse, it's new for us, and I think it's probably new for everyone. Deirdre's going to drive while I talk, and then she's going to jump in. So we're going to try and keep this somewhat flexible. A little bit about ourselves. I am a research data management librarian. We both work in the ASU Technology Services Department. I'm also the director of our new research data services for the library. Deirdre is our systems architect. So she stood up ASU Dataverse, she configures it, she maintains the platform, and she's also working on many other non-Dataverse activities while doing this. And she's also providing rich customer support to help our research teams get their data sets into Dataverse. We kind of work together on that. A little bit about what we're going to talk about is we'll really talk at a high level about how this project came to us and how we decided to move forward to support them. Deirdre's going to really show how she configured Dataverse, the roles and rules that were applied, other customizations, and then how she worked directly with the team's technician to get the large data sets ingested and then published. And then we'll also cover how we adapted our approach since this, because it was all new to us, and then what we'll likely be doing moving forward with this and other requests that come in like it. So go ahead and jump to the next slide, Deirdre. Thanks. So this is kind of the project as it currently exists in ASU's Dataverse. It's a climate study, it's future projection, it's multi-decades, it's big, all right? The PI contacted us that they were trying to find a home for an extensive amount of climate data, and they were not sure if research administration or the library would be able to provide support for it. And honestly, we weren't sure if they just needed a storage solution because they had a timeline and they needed to get off research's scratch space, research computing scratch space, or did they actually want to publish their data? So they reaffirmed they intended to share this data, that it would be as used to anyone who could benefit from this climate data, and it was unique. And I also want to paraphrase this, that we are a generalist repository. So I am not a climate specialist. You know, looking at this stuff, I wouldn't really know the data, like the details of it. So we started talking more about it, and we wanted to know what they meant by extensive research data. And according to them, it was tens of terabytes of NetCDF simulation data files. So this is when the conversation really took off. And we needed to make some decisions about moving forward. So this is it in 7 seconds.
Neither of us can do this alone, so we gotta do it together, right? You with me? So let's do this thing!
Yeah, that was it. We're just like, let's just do it. Like, we're gonna move forward, we're gonna figure out this out, and it's gonna be a learning experience for all of us. So again, they told us they had about 15 to 30,000 different simulation files that they would like to store in Dataverse. The simulations represented climate and urban development scenarios. They said they had tens of terabytes of files, okay, of data size. One challenge for our team was to find a way for the researchers to transfer their files directly from the research computing's high performance cluster center into Dataverse. And then we also learned that the documentation, the methodologies and all of that was wrapped up in external publications. So we would need to work with them to get as much of that information about the data set as we could before publishing this data. And Deirdre, I'll let you jump in at this point. I think you might be muted. Deirdre, I think you're muted.
Sorry about that. So anyway, and note that the structure and organization of this data set changed over time. Initially, the client was talking about uploading thousands of smaller files from 80 to 150 meg in size. By the end of the project, though, they had decided to zip those files into very large zip files, and the resulting files were anywhere from 150 gig to 365 gig in size. So in the process of making these changes, the files were uploaded, deleted, and re-uploaded several times, which caused some concern later on in the project, which I'll talk about in a few slides. So I know this panel is mostly about alternatives to cloud storage, and we are using cloud storage, namely AWS S3, but part of this project involves finding small configuration tweaks and efficiencies that will help us cut costs in the long run. We're also testing some other S3 protocols with Dataverse, such as Wasabi, and we're looking at transitioning to a local Dell Isilon solution, but we haven't done enough testing on that yet to present about it. So we recognize the need for finding an efficient way to allow our researchers to upload a lot of files in bulk, as well as many of them being very large files. As like what the multi-part direct upload that Jim was talking about was in Dataverse 5.1, I believe, which was around October 2020. Guys, correct me if I'm wrong. And we started working with this researcher in early October 2020. So this was really timing for us. We were excited to see that. We were able to utilize the direct upload feature. Can you guys hear me? I just got to notice that the internet is unstable. This direct upload feature of Dataverse allowed for uploading files larger than 5, uploading them directly to S3 and the Dataverse interface, as Jim was talking about. We created a file store in Dataverse that included the upload configuration, and that store points to the same bucket, the regular store. So we have one bucket, multiple routes for getting data into that bucket. In addition to the direct upload functionality, we also needed a way to bulk upload all of these files at once, whether it be the smaller thousands of files or the large zip files. There were still a lot of files. So we worked closely with Jim Myers, who is amazing, who offered an immense amount of help in troubleshooting issues and also gave us the beta version at that time of the DVUploader tool, which retried failed multi-part uploads, which was an issue that we ran into. Speaking of which, initially when our client started creating these large zip files, the uploads kept failing. We kept seeing that the parts they were stopping at a certain part. We finally realized that we needed to set that parameter, the AWS pre-signed URL parameter, to a higher value. I think the default is an hour. And so we set it to 3 hours. And once we did that, the jobs were successful. So some of the pitfalls, I mentioned before that we were dealing with a lot of files and many deletes and re-uploads. We found that this was significant in relation to how AWS S3 handles file versions. First, it looks to me anyway, in looking at all the data, that if you delete a file in S3, it doesn't really actually delete the file. It creates a new version of the file, which is a delete marker, and it retains the original copy of the file as a previous version. Also, when you transition a file to a different storage class, which we were doing to save storage cost, it doesn't just change the storage status of the current file, it creates a new file in the second storage class. So you have multiple versions of a file, the same file. So we were moving the files to intelligent tiering to save money, but now it actually looked like it was going to cost us more because we're paying for 2 files or 3 files or however many. And finally, Dataverse manages its own versioning, and it's not aware of S3 at all. So if a user replaces a file in Dataverse or deletes it and re-uploads it, the second file is actually considered a new file in S3. So again, you have multiple copies of the same file, which adds up to increased costs that we weren't expecting. So in our case with our researcher, there was a lot of uploading and deleting of files going on. So if we look at the number of pages of files in the bucket, without showing versions, we have 2 pages of files, which is about 500 files. If we show the versions, we have 44 pages of files. So that's roughly 15,000 files. So it was keeping all of those versions. So we found ways to go in and tweak some of our configuration settings as far as like how to, versioning and saving previous versions of files to reduce that cost somewhat. The last thing we realized was if our researcher was going to be uploading 30,000 files, we probably didn't want to have file level DOIs turned on. So we quickly disabled those before he published his data set, because that would have pretty much used up like half of our allotted DOIs for the year. And ultimately we got all of those files uploaded, and the upload part of that, once we got the tweaks figured out with DVUploader, was really very smooth. It took a long time. I think he mentioned 24 hours for one of those zip files or something, but he did get the files uploaded. We still have some reservations about how useful the format of 155 gig files is going to be for the users, because downloading those is going to be a pain. So we're probably going to still have to work with the researcher to maybe come up with a better solution for that. Now to you, Matt.
Thank you. So really the benefit of this project was just what everything that Deirdre just talked about. It was a learning process, experimenting with the direct uploads. Again, we do have questions about the usability of it in the end, but we're glad we did this and that our administration supported us in doing this, because we were able to break the eggs to make the omelet. There was a lot of back and forth between us working through and the research team working through these unknown expectations. They wanted to share their data. We wanted to make sure we could do it without breaking the bank, and that sharing it via Dataverse actually makes sense. We did not anticipate how they were going to work with the system, deleting and re-uploading files and then changing the way that we're going to do it. So we learned we need to communicate that Dataverse is another form of publication, just as important as publishing your article. And it's not a test bed for trial and error when you're getting ready to do it. So we needed to be upfront, request information and documentation early. For example, would a lay person know what they were looking at when they came across this data set if they discovered it in our library catalog? So we have to ask again for documentation. And sometimes it was just about us getting on the same page and understanding we're using different terminology for the same thing. And Deirdre, you had a couple of other things you wanted to add there too, I think.
Yeah, I just wanted to mention that we had some issues with permissions, because we had initially given the researcher admin permissions in order to upload the upload it. So we created a custom permission that allows without having all of the other admin access. We also realized throughout this project that we really need to make sure that our research have a clear organization structure, especially if they have a lot of files, before doing any uploading. Matt designed a README file that provides detailed metadata about a data set, and we recognize the need to have our users complete that before they even start doing any editing of their data.
I think Deirdre broke up there, but just to kind of cap that off, we realize other organizations probably face similar challenges, and we welcome any advice or suggestions on better approaches. We'd love to talk to community members who are facing these same issues, and that's us. So thank you.
Great, thank you, Matt, and thank you, Deirdre. I think some of what Jim was describing is some improvements that direct to storage uploader might help you. So that's great to hear. There's lots of stuff going on in the chat. I'm gonna pass it over to our final presenter. So Vasilidis, sorry if I didn't pronounce that correctly, Vas, I didn't practice before, but is the Chief Customer Officer at Globus, based at the University of Chicago. And Vas's presentation today is about Globus and Dataverse towards big data publication. And I'm really excited because this is a project that we're working on with them. So take it away.
Great. Thank you, Amber, and thanks for the opportunity to present to the group. As Amber said, I'm Vas Vassiliadis. I'm with the University of Chicago, but I'm actually with this odd group at the university called Globus. And we are really operating, you can think of it as a little startup within the university. It's actually no longer a startup. We've been around about 11 years now, but offering this data management service to researchers and trying to do it in a sustainable way. So just for those that are not familiar with Globus, which I imagine is probably a lot of people on the call, although I do see some familiar faces and names. As I said, we've been around a little over a decade. We've got a pretty large install base. The majority of our users are within higher education, as well as a lot of federal agencies. We also have commercial customers that use us, but that's a minority. We're funded by, the development is funded by a lot of the usual suspects, but as I said, increasingly we're moving to a model where we're covered by subscriptions that many of our users choose to sign up for, and we're very grateful to those. So what I want to do is just give you like a very high level overview of how I like to sort of present what we do, and at first order, the thing that we do best, I think, with Globus is give researchers a way to access all these diverse types of storage in a very unified way through a web browser, through command line tools, through other things. But they basically look the same no matter whether you're accessing AWS S3, some other S3 compatible system, Lustre, GPFS, what have you, your laptop. And so it really does simplify people's lives when they have to move and share data between different systems. We have connectivity to a lot of the commonly used object stores, as well as all of the POSIX compliant systems out there. And we continue to add to this list. And I've made a mental note to reach out to Ben after this to talk about storage and see how we can definitely get plugged into that effort, because that's really exciting. So obviously research is collaborative, and we have a need to share with people at other institutions. So there's a lot of ad hoc sharing that we enable. We also work a lot with instruments and data coming off instruments, and it's becoming increasingly important to make these working data available to people at various stages, and do it at scale. So we have a lot of capabilities for automating some of that. But really, once you get past that, and you want to make reference data available to the community, let's say, which is a common application, this whole data publication challenge is one that we tried to solve sort of in a turnkey fashion some years ago. we had a service called Globus Publish, and it turned out that we sort of completely missed the mark because we try to make it really nice and turnkey. So you come to one web app and you have the ability to set up your collections and put data in there and use some of the robust file transfer and sharing capabilities of Globus behind the scenes. But and this was a joint thing with DSpace at the time, and it didn't quite work out because a lot of what people have, as everyone here is aware, is they have their own repositories. They've got different ways of pulling their data together. So the need really was to provide the supporting pieces for getting data reliably into these systems, and also allowing people to pull the data out of those systems reliably. And I think it's telling in a lot of the previous talks, mention of how to deal with the sheer size of the data, and the fact that trying to pull some of these things down through HTTP, sort of like sipping petabytes through a straw is really kind of a challenge. So they say you should never apologize in a presentation, but I will apologize and say that even though we've been aware of Dataverse for a long time, we've never sort of really paid attention to what we could do together. So in part, I'm really glad for the efforts of the Scholars Portal team, Amber and Amaz and others at the University of Toronto, and sort of making us, bringing us back into the fold and having us sort of re-engage in this conversation. We did some work as part of the Hotel project that I show up here at the top, where Globus was used to pull data into Dataverse, but that's sort of by the wayside in some sense. I also recently became aware of the Synapse project that's done some integration with Globus. So there are a number of efforts out there, and we've been peripherally involved. I think we've been a little more involved with the Scholars Portal folks, but there's definitely, from my perspective, a need to engage in a more programmatic way with the Dataverse team. So as much as anything, this discussion is sort of my call to action, and to sort of get with the team and find sort of the optimal way to integrate Globus into these environments. And the design pattern that we've seen elsewhere, and I think is probably going to be relevant here, is that some people I think alluded to this, the fact that the data storage is sort of separate from the web app, the portal, Dataverse, whatever the case may be. So people will come to the web app, they'll search, discover the things they need, and then when they want to get the data, trying to do that through the portal can often be a real challenge. So one of the things that we've done particularly well with a number of large projects is to have them build their own portals and allow them to make lots of different types of external storage available, such that when you actually say, get me the data, there's a direct path between that storage and your own system. And if it's small data, order, megabytes, maybe a couple gigs, you can just do it directly through the browser. But more often it's becoming necessary to do it in a more reliable fashion using the managed file transfer mechanisms that we provide. So that's something that we've done a lot of, and I'm hoping that we'll be able to sort of mirror in some sense this design pattern with Dataverse essentially, being this box here and having this really rich and diverse set of storage systems just easily available without requiring the researcher and IT folks to really deal with that at a detailed technical level. A couple of the examples of where, just to give you a feel for what I'm talking about, we've had folks doing this, as I said, outside of Dataverse. So I'm hoping at next year's meeting, I'll be able to share, perhaps Scholars Portal or other systems that have Dataverse as the front end. But the NCAR Research Data Archive is one example. Whoops, sorry. Materials Data Facility is another one. And I thought I would just give you a quick look at those. If we have time, someone can give me a time check. So this is the Research Data Archive. So it's just a portal. So this could just as easily be Dataverse, where people come along, find, and I'm sure a lot of people on the call are familiar with climate science. I am not, but let's say I did want to find, and access some data here. And there's various mechanisms for searching for it. But once I find the data that I'm looking for, then one of the options is to get it via Globus. And when I do that, I get this little pop-up that says, okay, we're gonna grant you access to this data set. So when I do that, I can essentially open up this window, and I'm in the Globus application, and I can go ahead here and log in with my university credentials, and I'm literally dropped into that that data set, and I don't know what storage system is behind this archive. It's a multi-petabyte archive, but this is a subset of the data that I'm looking at, and then I can just go kick off a transfer and move that to some other system that I have access to. So that it's that level of ease and convenience that I'm hoping we can bring to Dataverse users with some more programmatic work. Another example is the Materials Data Facility. They actually happen to use our search service to do faceted search. So again, here I can narrow down the set of data that I'm looking for, and then click the Globus button and just get it. And so the key point here is that it reflects this design pattern that I mentioned earlier, where you've got the data separate from the portal. And so once you find the data you want, you fire off that transfer, you can go away, and you'll get notified when it's done, and off you go. So I'll just leave it there, because I know we're a little past time, and I want to leave plenty of time for questions. So thank you again.
Great, thank you, Vas. This was a great introduction to how Globus could be introduced into Dataverse. So there's a bunch of questions that have been put into the chat. Oh, Gustavo's just mentioning if you're interested in seeing more about the Globus upload external tool that can be connected to Dataverse. They're showing a demo this evening in the integrations and external tool session. Great. Okay, so I'm going to go over to the questions in the notes document. If you're all, I'm going to put the link to that in the chat so you guys all have it. And some of them have been answered already, so I'm going to skip over those. But
do you want me to share my screen, Amber? I have the notes document.
Great. Okay, that sounds good. So we'll start off. This one's about how to combine S3 upload to Dataverse with something like Baggit, so Uploader can be sure all files are uploaded with correct checksums, ideally without having to do local download again. So what do people think? Is there any solution there for maybe if you're storing files externally for preservation, accessing those via that mechanism? Jim, did you want to maybe answer that first?
Yeah, sorry, I think I tried to answer that in chat as well. I mean, one of the things I think is a difference between what Dataverse is talking about and what we saw both in Globus and this question is that, that often the data set has one set of access, and in Dataverse, we have a data set that has lots of metadata, and then we have files, some of which can be restricted and not. And so the data sets actually have all of the metadata. In fact, we have lots of metadata exports that have the checksums in them. And then you can download the files, but if you want to have all the checksums, you essentially get that information from the metadata exports, and then you can use the links in the metadata actually to go download the files if you want. So we have a lot of Baggit and OAI ORE support, and so things like the API and the DVUploader can check checksums going up and down. We can export things for archival purposes as a bag, so that the checksums and the metadata travel with the files. It's just, I think that the UI mechanism sort of treats the files much more like individual files that you go get that file and the metadata you look at, or you download the metadata separately rather than having it all packaged together.
And I will add that we have done work integrating. So we've got BD bags integrated with Globus on a few projects. So you actually can get that capability. That's in place for actually one of the portals that I showed you. I didn't show you specifically that one, but they have essentially BD bags where they create a manifest of files and their checksums, and it all gets managed as a cohesive unit.
Great. Okay, I'm just looking for next one. So this one is just to clarify, but I think it was interesting. So there was a question, am I understanding correctly that storage locations can be configured on a per collection and a per data set level? So this is a new feature in Dataverse. And Danny, do you want to just maybe explain how that's working in Dataverse so everyone's on the same page?
Yeah, I'll be happy to. So as I mentioned in chat, at the Dataverse collection level, this is settable through the UI under Edit Collection, and it's only accessible to super users. And you can also, it's only accessible and only visible to super users. You can also set it by API, and then at the data set level, you can set it using API only.
Great.
Yeah. And I think it's been set at admin mostly because both there are costs and size limit constraints on those stores, right? So if you open it up to let any user do it, you're essentially opening yourself up to those users getting access to larger data and costs. And so we've, at least for now, restricted it to admins having to be in the process.
And with regards to direct upload and download, has anyone looked into how to couple that with encryption? There was a question about, is there any experience with combining this with encryption on the client side, for example?
Yeah, I don't think there's been any, I'm not aware of any encryption going on in that. I know you can set up your S3 like at Amazon or whatever with encryption on their store, but I'm not aware of anybody doing anything to encrypt, other the transfer itself is encrypted with HTTPS, but the file itself is not getting encrypted before it goes up or anything.
Yeah, this has been within the storage network. Actually, client-side encryption is one of the default options. We also have a hosted gateway where we do server-side encryption, and there are pros and cons of each. One of the interesting things, though, that we've found is we sort of combine access grants with encryption. So that allows you to be decentralized in how you give people access to data. Essentially, if they end up with the hierarchically determined keys, they can decrypt it. If not, they don't. And that sort of allows you to securely share data that needs to be securely shared without having a whole lot of the overhead of changing access control lists and things like that.
Sorry, Ben, what did you say you were combining with encryption?
Oh, sorry. Access and encryption.
Oh.
So that sort of they in essence, if you're giving people a grant, you're giving them a portion of the key that they need to decrypt the file. And that allows you to sort of give certain people access to certain files or have certain rights to read or write without having to maintain an access control list, a centralized access control list, which can be compromised.
Great.
But yeah, the client-side encryption these days actually can be done really very, very quickly and very little overhead. When I was showing you the video scrubbing, there was actually client-side encryption involved there. So it's not a big performance overhead.
Yes, we're learning more about the need for encryption in terms of sharing sensitive data, perhaps. So this is really interesting. Okay, I'm going to go to another question. This one's about Globus. So does Globus require an endpoint installed on the data storage server? And are the downloads via Globus trackable within Dataverse? Is access to those downloads restricted to a path through Dataverse, or could those Globus download files be shared independent of needing to use the Dataverse record? So I'll just start off. So the setup that we've been looking at is that we require our own endpoint, but VAST did show a solution that wouldn't require you to do that. But VAST, please explain more about how endpoints work and how that is typically set up for transferring data between locations.
Yeah, sure. So you do need an endpoint. It doesn't necessarily have to be on the storage system. It can have the storage system mounted. It can have it be remote, like with S3 type systems. It's typically remote because you're not mounting anything, obviously. But you do need an endpoint that the Globus service can talk to. As far as tracking the transfers, the API gives you all the mechanisms to track that. Is tracked in our web app, but obviously if you're going to build that into Dataverse, I don't think that's been done within Dataverse itself. I think, Amber, maybe you guys have put a progress indicator of some kind inside the Scholars portal. I'm not sure, but that's certainly one of the things that's very, very easy to do by talking to the API, so you could track it through Dataverse. As far as how you download files, the restriction is not really with Globus. I mean, it's really, if Dataverse is front-ending it, then what you would need to do is make sure you have the appropriate permissions within Dataverse. You can flow those permissions through to Globus. We may actually do maintain an access control list on all of these collections. So there's different ways to structure that, and I'm happy to go into it in detail offline if you reach out to me. I think there's a number of different ways to architect that, but it's all very doable.
Yeah, and I'll just jump in that as much as possible, we're hoping that the Dataverse system would handle the tracking of all the things that it would normally do, including downloads. It's just that the mechanism in which you would do so is through Globus. That's how we've approached this integration, is all of the things that Dataverse does, permissions, checksums, downloads and containerizing of the data itself. And then that's all still happening. It's just a matter of how do we get data into it and how do we get data out of it. And Globus is being used as that transfer mechanism between the system and the storage. Okay, great. Are there any other questions in the chat? I'm just looking. So I'll go to Peter's question in the chat. So is the multi-part upload for multi-gigabyte, terabyte files only supported through the UI for an S3 endpoint, or does the native installation support large file uploads?
Yeah, so at this point, there isn't support through files. And I think essentially that's because with S3, it's sort of baked into the protocol that multi-part with pre-signed URLs existed, and we just hooked up to it. With files, I think we'd either have to go find or build our own solution to break the file into parts and put it back together, which I think could be done. But as I put in the chat, at that point, is it easier for you just drop MinIO in front of your file system and use S3 rather than trying to do the extra development?
Great. So there were some questions for the panelists that were prepared in advance by the chairs. So I'm just going to go ahead and answer those. We have about 4 minutes left. So what approaches can be used in the process of making large data sets available on remote storage so that this is as cost effective as possible? If you have any suggestions. Maybe we could start with Ben.
Sorry, I was muted. So, I think that in general, what we've tried to do is set up a system where we take advantage of the fact that most of the drives in the world are only using a fraction of their available capacity, and yet they still require all the same amount of people and power to run at 25% capacity as they do it at 80% capacity. So a lot of the design of our system is to take advantage of economics and say that prices should come down for storage over time, and they have, but they haven't come down for cloud storage. And so by sort of using the right sort of underlying economic model, we think we should be able to have prices continue to come down pretty dramatically over time. already starting at 1/20th to 1/40th of the price of S3. And because you're storing data at the edge, you end up avoiding a lot of the even bigger cost than storage is the bandwidth usage, right? And so if you can get data closer to where it's going to be consumed and created, I think that general philosophy ends up making it far more cost efficient, not only now, but over time.
Great. Is there anyone else? Jesus, do you want to chime in, or another panelist?
No, actually, I don't have any thoughts on this. We could move to the next question.
Okay, sounds good. So are there any best practices regarding what data should preferably be shared on remote storage versus local storage? Is there anyone willing to take that one?
So I'll jump in and just make an observation on that sort of related questions here. And that is that in a lot of use cases that we've seen, it just makes sense to leave the data where they are. Maybe because it's not really relevant to share with in a public manner. Maybe it's just it's a more community with fewer members or whatever, and it's just the hassle of moving it, and the fact that a lot of these institutions do have large scale storage, archival storage that's pretty cost effective. So deciding what to put remotely, sometimes it's put the metadata remote and make it more broadly accessible, but then have more fine-grained access controls to decide who can actually get at the data themselves. We're doing that, for instance, with the Cancer Registries project with Pittsburgh, where you've got these different levels of control of both metadata and data, and the data are actually at the respective institutions, and yet there's sort of a unified portal that federates all of these on the front end.
Great, thank you, Vas. That's a great answer. And I think we'll learn more about these types of things as we move along and integrate with repositories and seeing how these remote storage are sustainable over time. So we are at time. Thank you so much to everybody and all the questions, and to all the panelists. We very much appreciate it, and you can go back and see all of these questions in the notes. Thank you to Laura for taking the notes. And thanks again to Jesus and Sonia and everyone at IQSS who's been helping with these sessions. Take care, everyone, and off to the
Thank you very much.